We should define the different types of memory, although all memory is going to consist of a memory cell and a decoder. So the memory can have sequential access to the memory cells or random access. Sequential access would take a different amount of time to access each memory location versus random access. Memory could be static or it could be dynamic. It could be volatile or it could be non-volatile. So let's understand each of these. So a sequential memory, examples of that are a magnetic disk drive or a tape drive if you've used them. So the access time depends on the current location of the read head compared to the word in memory. So that access time, how do we get to that memory address? We have to get to it sequentially. So that access time is variable and it's indeterminate. It depends upon where the read head is left off. So it's indeterminate each time for each space, each same address in memory, how long it'll take. Whereas the beauty of the random access memory is that access time is the same regardless of the location of the word in memory, and that access time tends to be measured in nanoseconds. So that's sequential access versus random access. Let's look at static RAM versus dynamic RAM, and we use SRAM or DRAM for there. So in our SRAM, the data is stored in internal latches. Those latches will maintain that state as long as the device remains powered, has a voltage applied to it. It's easier to use and it has shorter read-write cycles. The dynamic RAM, the data is stored in the internal capacitance of transistors. So the capacitance tends to discharge with time, and we need to periodically refresh what's in that memory. So it has to cycle through every few words or through all the words every few milliseconds and restore the charge on that capacitor. But the advantage here, so that's extra time to do that, but the advantage here is that there's lower power consumption. It's just stored in that capacitor, and the density, we can get much more memory, many more memory cells in the same real estate of a dynamic RAM than in a static RAM. So we have larger storage capacity on a single integrated circuit. Volatile versus non-volatile. Volatile means you lose the information when it's powered off. So our integrated circuit RAMs can be both static and dynamic, but they are volatile, meaning they require power, the device to be powered on to remain stored what's in that memory. Non-volatile memory maintains the information even if it's powered off. So magnetic disk drives or the flash drives, that information, well, magnetic disk drives, the information stored by the direction of magnetization, and that stays there. That's non-volatile. You have to demagnetize it. It doesn't require electrical power. A ROM type of an integrated circuit, it's not writable, but it maintains that information after the power is turned off. And then, it says, programs or data transferred back to RAM must be transferred back to disk when it's powered off. So the different types of ROMs, we can have, electronically erasable ROMs, and those flash ROMs that the digital drives that we have now aren't really magnetic disk drives anymore. All right, so that's different types of memory. We'll talk about memory decoding in the next video.